Sandha, I am a PhD student at IIT Delhi and University of Queensland under UKDAR program. I am a TA for today's session. So let's start. So this is 7th tutorial. First, I want to discuss briefly about some question regarding Compton scattering. We know what is Compton scattering. The professor has already described in the class that this is a quantum mechanical phenomenon basically. But here we introduce the momentum conservation and energy conservation to solve this problem. So a photon of wavelength lambda incident on a rest electron, and it gets scattered at angle theta, and its wavelength changes because the energy changes and electron gets recoiled. Okay, so that is basically Compton scattering. Basically the Compton scattering, the most useful formula is lambda minus lambda dash, lambda dash minus lambda, because energy loses, photon loses energy, that is frequency decrease, so lambda increases. So lambda dash minus lambda is equal to h by mec 1 minus cos of theta. This is called photon wavelength. It has a value of 2.426310 into 10 to the power minus 12 meter. For our simplicity, we will take 2.43 picometer. And this is the theta between the previous, between the direction of a photon, like incident photon and scattered photon. Always remember that this is the theta, not that angle. We can say phi. And if you remember this equation, that is enough for Compton problem to be solved. But there are another kind of equation that like gives you how much energy, kinetic energy changes of electron, what is the relation between theta and phi. But if you able to write the basic linear momentum conservation and energy conservation, and if you remember this rule, you don't need to remember that kind of jargon rules or equation. You will be fine. And so let's start with the question number 1. Question number 1 says a beam of X-rays of wavelength 0.2 nanometer is incident a free electron and gets scattered in a direction with respect to the direction of the incident radiation, resulting in maximum wavelength shift. What is the wavelength of scattered X-ray? So we have been told that the shift is maximum. So this entity will be maximum when 1 minus cos theta will be maximum. So this will be maximum when cos theta is minimum. Cos theta value varies from -1 to +1. So this is the minimum. So then theta is equal to 180 degree. So we know lambda dash minus lambda here. Two 2.431 minus cos theta. So this is 2 into 2.43. So lambda dash will be lambda plus 2.43 into 2. So we lambda is equal to 0.2 nanometers, so that will be 200 picometer. So 200 plus 4.86, so that will be 204.86 picometer, and that will be sorry, okay, so 0.20486 nanometer. Now if we extend this part, like question, this is A, we extend the question that find the percentage energy loss of the incident radiation. So energy loss delta by delta E into 100, that we need to obtain. So delta E will be h nu minus h nu dash by h nu into 100%. So that will be mu minus mu dash by mu into 100%. So that will be C 1 by lambda minus 1 by lambda dash by C 1 by lambda into 100%. So that will make it lambda dash minus lambda, lambda into lambda dash into 1 by, into lambda into 100%. So lambda cut out. So lambda dash minus lambda, we know that is 2.43 into 2. And lambda dash is 204.86 into 100%. That will be 2.4%. So 2.4% is the energy loss. Then I want to discuss another kind of question, that is calculate the maximum percentage change in wavelength of 10 angstrom incident photons in Compton scattering. So here, instead of delta E by E, we need to calculate delta lambda by lambda into 100%. And we know delta lambda is equal to lambda dash minus lambda, which is H by M is C1 minus cos theta. And that is 2.43 Compton wavelength, 1 minus cos theta. So here we have said that maximum percentage change. So maximum change will happen, but I have already discussed that when cos theta is minimum, and when cos theta will be minimum, that means it is minus 1. So 2.43 into 1 minus minus 1, that will be 2 into 2.43, and that is 4.86. So, interestingly, see here that it is basically delta lambda by lambda dash. Energy, what percentage of energy does change is lambda, delta lambda by lambda dash. Here, what percentage of lambda change or wavelength change? That is delta lambda by lambda. It is 4.86 by, that is in picometer. Let it all take into meter. Don't, like, you can also take it all into nanometer or picometer, but just take all those things in meter. That will be easy. Not easy, it's like time saving. So that will be 4.486%. Another question. The kinetic energy of the, sorry, photon wavelength 0.5 angstrom scattered at 90 degree. So the kinetic energy of the recoiling electron will be the same the energy photon loss. So that is h nu minus h nu dash. So basically that is h into c1 by lambda minus 1 by lambda dash. So lambda dash minus lambda. We know lambda dash minus lambda is 2.43. 1 minus cos theta. For theta is equal to 90 degree, cos theta is equal to 0. So lambda dash minus lambda will be 2.43. And now put all the values here. We have to put hc value in electron volt. So that will be 1.26 into 10 to the power minus 6 electron volt into 2.43 picometer by 250. Here lambda is 2.5 angstrom. 2.5 angstrom, and that will be 250 picometer. And lambda dash will be 250 plus 2.43 picometer, which is equal to 250 2.43 picometer. So that will be 252.43. All of this will be equal to 48 electron volt. Okay, now if they ask what is the velocity of the electron, so K is equal to half of mv square. So V is equal to root over 2k by m. Here change all the thing in 2 into k is 48, but it is an electron volt, so convert it in coulomb. 19 coulomb by mass 9.1 into 10 to the power minus 11. Okay, minus 31, not 11, which will be equal to 4.107 into 10 to the power 6 meter per second. So here we have discussed how to, when angle is not given, or how to calculate the Compton shift when angle is given. When angle is not given and it says the maximum, so we recall that theta is, we will take cos theta is equal to -1. So that will be double of the Compton wavelength. And when we say the wavelength shift is minimum, that means the wavelength shift is 0, that then cos theta will be 1. That means theta is equal to 0. That means there is no scattering, basically that's the meaning. And when theta is 90 degree, we know the cos theta is 0, so the wavelength shift is 2.43 picometer. And how to calculate the energy, how much energy has changed in percentage, how much wavelength has changed in percentage, how to calculate the kinetic energy of the electron. Basically, it is basically equal to the energy photon has lost, and from that velocity of the electron. Now we jump to center of mass problem. So let me write question 1. So the Earth has a mass of 5.98 into 10 to the power 12 kg, and the Moon has mass of 7.35 into 10 to the power 22 kg, and their center of the distance between their center is 3.85 into 10 to the power 8 meter. So we are asked that how far from the center of Earth is the center of mass. So we need to calculate, that is Earth, that is Moon. So we have to calculate the center of mass from the Earth distance. So we take its coordinate in x-axis is 0, and this coordinate is 3.85 into 10 to the power 8 meter. Okay, so x center of mass is equal to I mi xi mi. So that is m total basically, and this is m earth to x earth plus m moon into x moon. Okay, so m earth we know that is 5.98 into 10 to the power 24 into 0. So that will be 0 basically. And 7.35 into 10 to the power 22 into 3.85 into 10 to the power 8 meter. So that is kg into meter. Here we will say this is 598 into 10 to the power 22 kgs plus 7.35 into 10 to the power 22 kgs. So basically it is 5.35, well that is 7 to 10 to the power 22 kilos, and here 7.35 into 10 to the power 22 into 3.85 into 10 to the power 8. It will be kg into meter by kg, it is meter. So basically this thing and this thing will cancel out, and we will get 4.67 into 10 to the power 6 meter. So you can see the center of mass is more like close to Earth than Moon. But if the same question will be asked in a way that how far from the center of Moon is the CM, then you see that x Earth would have been 3.85 into 10 to the power 8 meter, and x Moon we should have to consider 0. So then also we will get the same point, but the answer will be different, because then we will be like obtaining this value. Or we can go this way and minus 4.67 into 10 to the power 6 meter from the actual distance. Then we will also get the center of mass from the Moon. Okay, question 2. There is a system given So this system is given. So there are three blocks of like you can consider it as a plank or brick. The mass length of these bricks are L and mass M. So basically their center of mass is in between, and its center of mass will be there in the middle point. This center of mass will be in its middle point. Middle point, according like if we take the center here, this is X, this is Y, and we are not given this length, but this is the middle point of this length also, and consider it Y dash, and all has same Y dash. So this distance is L by 2 and this distance is L by 4. So basically this distance will be L by 2 plus L by 2, and this distance will be L plus L by 4. That is the x-axis coordinate of center of mass of this bricks. That is L by 2. Now we have to calculate center of mass of whole system. So X center of mass is basically xi summation of mi. So that will be m into L plus m put by 2 m into L plus m into L plus L by 4 by 3m. It will be ml by 2, 2 ml by 2 plus 5 ml by 4 by divided by 3m. That will be 11L by 12. So this is the center of mass in x direction from this point, from point A of the system. Now, tricky question. Balance a 35.5 kilo tire automobile tire and wheel, a mechanic must place 50.2 gram lead weight at 25 centimeter from the center of the wheel. When the wheel balanced, its center of mass exactly at the center of the wheel. How far from the center of the wheel was its center of the mass before the lead weight was added. So the question is that there was an automobile tire and wheel like this. So the mechanic has to place, and the mass of the automobile tire and wheel was given, that is 35.5 kg. So the mass was given already, and the mechanic has to put a 50-gram weight. Imagine a 35 kilo tire and wheel we are talking about, and to balance it, a mechanic has to put a 50-gram weight at 25 centimeter from the center of the wheel. So the wheel is a like wheel is a circle thing. So 25 centimeter from the center, that the position of the placing is the ball is also a circle, but it has been put at anywhere on this circle. When the wheel is balanced, the center of mass is exactly in the center of the wheel. So the center of mass become this here. So it was asked that before placing the lead ball, where is its center of mass? So you can see that it be at first believe it's at first center of mass will be here or here, somewhere here. Before it was here, we put a ball here, then it became here. From that thing, we know that current center of mass should be in between of previous center of mass and center of mass of the ball. Okay, so here we take center of the wheel or center of mass of combined system at zero position. That means x coordinate of center of mass is 0. So x nu is equal to 0. So this x value of center of mass of whole system is basically m wheel plus tire into x wheel plus tire plus m lead into x lead by total m. Okay, so this is 0. This is here 35.5 plus 0.0502. We are considering whole thing in kgs. So this is 35.5 into something x wheel plus tire plus n lead is 0.0502. Here we take the position of the lead wall as a positive. Let us see where we get the position of wheel and tire. The center of mass position negative or positive. Positive, that means they are in the same side of the center of the wheel. Negative, matlab they are in the opposite side of the center of the wheel. So x lead is 0.25 centimeter meter, because we are doing like following the conservation of kg into meter. So center of mass of wheel plus tire would be minus 0.0502 into 0.25 by 35. Sorry, this looks like 504. 502. 5, which will be minus 0.354 meter. Let me calculate the thing. 0.0, calculate again. I have already calculated and written, but it is into 10 to the power 5. So it was at the opposites, the center of previous center of mass was at the opposite of the position of the ball. Now question number 4. Question says a hoop of mass m and radius r rests on a smooth level surface. The inside of the hoop has ridges on either side, so that it forms a track on which a ball of mass 2m and a radius r4 is released from the right. So most part of the system will rock back and forth until it comes to rest with the ball at the bottom of the loop. When the ball comes to rest, what is the x coordinate of its center? Moves when it can directly move from here, or it can be round at somewhere. Basically, when it became rest, the ball will be here and this center will have shifted somewhere. Okay, so we need to calculate where its center has will shift. M ball is 2m. First, we consider this is our 0 point. Okay, it is 0, and the center of mass of the hoop lies in its center. All the symmetric object has its center of mass at their center. And so for the ball. So the center of the ball was here. This is basically r minus r by 4 distance from the 0. That is 3r by 4. So we need to calculate the center of mass. Where will be the center of mass? See, if that moves in this direction also, then also the direction, it will be the x direction, and the x will be the same. So it doesn't matter if it is in right or at the bottom. It only matters that what will its center of mass, so that we can see when it will like stabilized, um, or the balls comes to rest, what will be the coordinate? Basically, when ball it moves from here, the whole system will move in this direction or that direction, some direction. So they hasn't asked the direction, they has only the position. So that will be m into 0 plus 2m into 3r by 4 by 3m. And that will be r by 2. So the whole system would have moved in r by 2 direction. Not r by 2, in x direction. So basically, when this ball moves and gets settled here, this thing will move here. Question number 5.
So from a metal stick, there are masses hanging. On the left are masses of 3 gram at 0.2 meter. Right. Okay. Basically, the stick, this is the center, 0. So if this is point 2, this is will be point 4. So at point 2, 3 gram, point 4, 10 gram. At point 5 here, there is 6 gram. So we need to put a 4 gram on the stick. So the center of the mass will be at the center of the stick. Here we put this thing as the x coordinate, here is 0. This x coordinate is 0.2, like let us take minus 0.2. This x coordinate is minus 0.4. This is the plus 0.5. Like from the intuition, we can see there are 13 gram in one side of the meter stick, and there are 6 gram in the another side, and we had to put another 4 gram in anywhere. So our intuition says it will be here, not there. But let us see via like calculation. So the center of mass of x coordinate of the center of mass will be mi xi by mi. So first 3 gram at minus 0.2 plus 10 gram at minus plus 6 gram into 0.5 plus 4 gram into that x direction. So it will be 3 plus 10 plus 6 plus 4. So that will be minus 0.6, 4 minus 4 plus 3 plus 4x. So that will be divided by 23. But we know that at last the center of mass of the whole system should be at the center, so that should be 0. So minus 6 minus 0.6 minus 4 plus 3 plus 4x is 0. So 4x equal to 4.6 minus 3. So that is x is equal to 1.6 by 4, that is 0.4. So it is positive, so it will be on the right side. Question number 6 is a 98 Newton person is standing on a road (1 meter) from the end the board balanced on a point that is 2 meters from the sea. The board is 4.9 meters. How long is the board overall? So basically, this is the board. So 90 this end, a 98 Newton person is standing. The board is balanced it here, 2 meter. And this is 1 meter. So we need to calculate how long is the board. So basically, if we find that board is a like symmetric thing, so if we find center of mass and like double it, we will get the length of the board. So first, the person's weight and the board weight has been given in a like Newton. We need mass. The weight is given, we need the mass of the person and the board. So 98 Newton is basically 10 kg. 4.9 Newton is basically 5 kg almost. This is 9.8 kg, and we, for the simplicity, we are taking the round figure. So here the system is, we are calculating all those things from here. The system is board plus person, and its center of mass is here. Not here. We are doing calculation with respect to A. This is X. So the system center of mass is at point -2, and mass of person into position of person plus mass of board into position of board is divided by mass of person plus mass of board. So that will be -2 by 15. Mass of person is 10 and its position is -1. Mass of board is 5 and its position is unknown. So after calculating all this, the X board is -4. So the center of mass from this end is at 4. So the whole length of the board will be 4 into 2, 8 meters. Now question 7. Here I am explaining this question in 2 ways, and you can see whether whatever approach you take, if you are right in your approach, then you will get the same result. So I can, then we need to calculate his length is 8 centimeter, this length is 4 centimeter, this is 6 centimeter, and this thing total is 10 centimeter. That means this is 4, this is 2, this is 2. Okay. Now calculate the center of mass of this system. Okay. So approach 1, that is addition method. So all three parts are symmetric. So their center of mass is at the center of figure. We already know this is 8 centimeter. This is 4 centimeter. This thing is 6 centimeter. That is 2 centimeter. And this is also 6 centimeter. And this is 2 centimeter. This is the center of mass 1. This is the center of mass 3, and this is mass 2. Okay. So this is XCM1. This is XCM2, YCM2, this CM3, YCM. So from the figure, you can see XCM1 because this is the half and YCM1 is 4. XCM2, this is 4 and 3, that is 7. And YCM2 is 1. XCM3, this is also 4 and half of 6, 3, 7, 6, and this is 1. So YCM3 is 7 centimeters. We get the center of mass of all the 3 components of the system, and here is given the density of mass is given as 5 kg per centimeter square. This is a, just imagine this is a 2D system. Okay, so the mass of N1 will be 5 kg into centimeter square into 4 centimeter plus 8 centimeter. So that will be 160 kg. and M2 and M3 are symmetric, right? So that will be 5 into 6 into 2. That is kg, 60 kg. So total mass will be 160 plus 60 plus 60. That is 280 kg. So now we need to obtain the center of mass of whole thing. So that will be MIXI. This is the x coordinate. And we will calculate the y coordinate separately. This is 280. So this is 160 into 2. This is M1, and we know this is XCM1. Plus 60 into 7 into XCM2 plus 60 M3 into XCM3, that is 7. When we add up all these things by 280, which will be 4.14 centimeter. Now, y coordinate of the whole center of mass will be MIYI by M. That we know 280. So 160 into 4 plus 60 into 1 plus 60 into 7. That is M1, which is M2, this is M3, which is YCM3, this is YCM2, this is YCM. And that will be 1120 by 280, that is 4 centimeters. So the center of mass of the whole system is 4.14, and in x-axis that is 4.14, in y-axis that is 4. So basically this is basically here out of the system. Now we want to see that via approach to the subtraction method we will get the same result or not. So via subtraction method, we will take two things. This is M2, this is M1. So M1 is 8 into 10, M2 is 4 into 6. Okay. The M1 is 5 into 8 into 10 kilo, that is 400 kilo, and M2 is 5 into 4 into 6 kilo, that is 120. So the center of mass of M1 would be at the middle point, that is 4, 5. X, this is 10, right? This is 8. So there
would be here, and M2 would be here. It is 6, so 3 and 4 here. So X CM1 would be 5 centimeter, Y CM1 would be at 4 centimeter, X CM2 we can see that is 3, but here it is 4. 4 plus 3, 7. The coordinate will be 7 centimeter, and same, this is 2, then 2, that is 2 plus 2, 4 centimeter. So they are in the same. So we can, like, from this thing, and from also the previous calculation, we know that its center of mass is going, whole system center of mass is going to, the y coordinate of the whole system center of mass is going to be at 4 centimeter. Now, the exponential center of mass of the whole system will be m1 x1 minus m2 x2 by m1 plus m2. That will be 400 into 5 minus 120 into 7 by, this is also minus. So 400 minus 120, that would be 2000 minus 840 by 280. So that is again 4.14 centimeter. And YCN would be 400 minus 280. 400 minus 127. And upward it will be M2 Y2. I don't know Y1 and Y2 is same, that is 4. So basically this is M1 M2, and here also it is M1 M2, so it is 4. So we got the same result. So whether you take the addition method or subtraction method, you are going to get the actual answer. So now move on to moment of inertia problem. That is question 1. Four particles, each of mass m, are kept at the corner of a square of side A. Calculate moment of inertia. No inertia about an axis. Passing through one corner. So basically 4 particles, each of mass A, marked at the corner of the square of the site A. So we need to calculate the moment of inertia about an axis passing through one corner. The corner, the axis is actually the parallel to the diagonal of the square. So the system. Is in R perpendicular square basically. So this is 0, 1, R1 is 0, R2 is this, half of a diagonal. So we know the diagonal is root 2 by 2. So that is A root 2. Or we can say that is A, this is A, this is 45 degree. So A cos 45 degree is also A root 2. And R3 is whole diagonal, that is root 2. So I would be m into 0 plus A root 2 whole square plus A root 2 whole square plus root 2A whole square. So this is will be 3 square into m. So 3m square. So it would be it will have unit of mass kg into meters or something like that. Because we are not given any unit in the question. Question 2. So basically,
This is center of mass. We know moment of inertia of a cube with respect to axis passing through center of mass is 1 by 6 m square. From the center of mass, we have to calculate moment of inertia of the cube around an axis which coincide with the side. So let us say this side. So this is actually the whole diagonal. This is the half diagonal. So basically A by root 3. So moment of inertia about the axis will be, we need to like invoke the parallel axis theorem. That is I is equal to m r square plus I is equal to m r square plus I z cm. So that would be m by root 2 whole square plus 1 by 6 m square. So that will be 2 by 3 m square. That is the answer. Now question 3.
So the question is the moment of inertia of a thin circular ring of unit mass is lying in the xy plane is 2 unit and 3 unit respectively. About the straight line y is equal to x plus 3 and y is equal to minus x plus 2. If the center of the ring lies at 1, 1, calculate moment of inertia of the ring about the axis perpendicular to its plane and passing through its center. So we are given moment of inertia about a straight line, that is y is equal to x plus 3. So y is equal to x plus 3, basically x minus y is equal to minus 3. So this is the line in y is equal to minus x plus 2. This y is equal to 2. So basically that is the line. And the circle is here. So for this point, we can like see that like these are the straight lines are almost perpendicular. So for one straight line, the moment of inertia is 2, the another is 3. So because of perpendicular axis theorem, first calculate the this one. Plus 3 is equal to minus x plus 2, so 2x will be minus 1. Of inertia of the circle with respect to minus half comma 5 by 2 will be 2 plus 3 5 unit. Because of because of perpendicular. This is one thing.
Okay. Because of perpendicular axis theorem. Now we need to calculate moment of inertia with respect to center of mass. According to perpendicular axis theorem, I z is equal to mr square plus I z center of mass. So here we need to calculate either center of mass, so that will be either minus mr square. We know either is mr square, so at distance we need to measure that will be distance from its center. So that is basically minus half whole square plus 5 by 2 minus 1 whole square. That will be 3 by root 2. So we have the circular ring of the unit mass, and this will be m into 3 root 2 whole square. So that will be 10 minus 9 by 2, that is half. That is 0.5 limit. That is the answer. Now question 4 is calculate moment of inertia region with respect to its axis. So the shaded region is this. Okay. So we assume this is y-axis, this is x-axis. So we assume there is 3 figures. This is 1, this is 2, and there's this 3. Okay. So basically this is 1, 1, this is 2, 2, and this is 3. So basically total shaded area is 1 plus 2 minus 3. Okay. So moment of inertia of hole will be moment of inertia of 1 plus moment of inertia of 2 minus moment of inertia of 3. So moment of inertia of 1 with respect to x-axis is ml square by 12. So this is actually y-axis.
Okay, this is 120 millimeter. This is 40 millimeter, and this is 20 millimeter. And density is not given. So we assume 1. Here it would be density into 1, A into B into here L. So we are measuring this with x-axis. So L will be, so this is not 40. This is equal to 50. So this is equal to 80 millimeter. So y is 80. So it will be 80 square by 4. So 120 into 80 cubed by 12. So G into millimeter square. That is 5.1 joule into 10 to the power 6 kg into millimeter square. Moment of inertia of mass 2, or you can say moment of inertia of 2 with respect to x-axis. That is half of a plate. So that will be mr square by 4. Here m is 1 into pi r square into r square of this r square by 4. So that will be half of pi into 40 to the power 4 into 4 also. So that is 1.01 into 10 to the power 6 kg. Moment of inertia of earth shape is MI3. That is circular plate also, because not only the circumference is unique, whole plate is unique. Whole area is unique. So that will be pi r to the power square by into r square by 4, and hence a is 1. So that will be 0.126 into 10 to the power 6 kg millimeter square. That is mr square. So total moment of inertia is basically I1 minus plus I2 minus I3. That is 5.12 plus 1.01 minus 0.126 kg into millimeter square. That is okay. Here is also 10 to the power 6. Millimeters into 10 to the power 6 kg. This is for today. Let's